Hello, my dear student. Myself Sanjay Sharma. I am a physics teacher from Rishikar Vidyapeeth, Sonipat. I am again here with my third module of class 12th, unit 1st, electrostatics. And our topic is electric field. Electric field is a region of space around a charge or a system of charges within which other charges, particles experience electrostatic force. Theoretically, electric field extended up to infinite, but practically it is limited to a certain distance. If we want to find out electric field strength of a point charge, then we can find with the help of this expression force upon test charge. If we have a point charge positive q and a test charge at a certain distance plus q naught, then if both the charge are positive, then the test charge will experience repulsive force, and we want to find out electric field strength at this certain position where the test charge is present, so we can apply the formula equals to F upon Q naught. If the source charge is negative, then the test charge will experience attractive force. Here, test charge is considered to be very small because its presence should not alter configuration of the charge or charges, and thus the electric field which is intended to be measured. So now आज का फंडा. Since test charge Q naught is taken positive, the direction of electric field is along the direction of electrostatic force. Electrostatic force of a negatively charged particle will be opposite to the direction of electric field. Third one is electric field is a vector quantity whose magnitude and direction are uniquely determined at every point in the field. Now SI unit of electric field is Newton per Coulomb. Now electric field due to a point charge. If we have a point charge at position O, you can see on the screen beta, if we have a point charge plus Q at position O and a test charge at point P, which is at R distance from the source charge, then the force experienced by the test charge equals to 1 upon 4 pi epsilon naught q naught upon r square. To convert the formula into vector form, we have to show the direction of the force, which we can show with the help of r cap. And then if we want to convert this r cap into the vector quantity, simply we have to multiply r in magnitude in numerator and denominator both. And our formula becomes F equals to 1 upon 4 pi epsilon naught q1 q naught upon r cube into r vector. Now the electric field strength is E equals to F upon Q naught, and then we get our desired result or desired formula as you can see on the screen. The electric field due to a point charge has spherically symmetrical. If the charge is positive, mean more than 0, then the field is radially outward, and if charge is less than 0, then the field is radially inward. This expression tells you that the electric field value or strength is inversely proportional to r square. If r square will increase, then the strength of the electric field will also decrease. Now, electric line of force. An electric line of force is an imaginary straight or curved path along which a unit positive charge is supposed to be moved when free to do so in an electric field. Electric line of force do not physically exist, but they represent a real situation. Electric field line of forces, they may be straight and they may be curved, you can see on the screen. Now, how can we draw these electric line of forces? If the charge is positive, mean more than 0, then the electric line of forces are always radially outward. And if the charge is negative, mean less than 0, then the electric line of force is always radially inward. Another, if we have a dipole mean two equal and opposite charges are having same magnitude but opposite signs are kept at a certain distance, that is called as electric dipole. So for electric dipole, electric line of force start from positive and they end at negative, or you can say in another way, Electric line of force contract lengthwise to represent attraction between two unlike charges. And if the charges are like positive charges as you can see, then electric line of force exert lateral pressure to represent repulsive between two like charges. Now, electric line of force due to a uniform field, they may always be equidistant and a straight manner. Now, the properties of electric line of forces, or you can say field lines. The electric lines of force are imaginary lines. Second is a unit positive charge placed in electric field tends to follow a path along the field line if it is free to do so. The electric line of force emanate from a positive charge and terminate on a negative charge. The tangent to an electric line of force at any point gives the direction of electric field at that particular point. Now, again, very important property for board exam. Two electric line of force never ever cross to each other, because if they cross to each other, then they show two different line of forces, two different direction of electric field at one position, which is impossible. Electric line of force are closer or crowded where the electric field is stronger, and the line spread out where the electric field is weaker. Electric line of force are perpendicular to the surface of a positively or negatively charged body, you can see. And electric line of force contract lengthwise to represent attraction between two unlike charges, and electric line of forces exert lateral pressure to represent repulsion between two like charges. The number of lines per unit cross-sectional area perpendicular to field lines is directly proportional to the magnitude of the intensity of electric field in that region. Electric line of force do not pass through a conductor, hence the interior of the conductor is free from the influence of electric field. And this is a very important concept, because if we want to protect any sensitive material which is very sensitive for electric field, that kind of material we can place inside the cavity of a hollow conductor, and then we can protect it with a strong electric field, and this phenomena is called as electrostatic shielding. And electric line of force can pass through an insulator. Again, I am telling you, electric line of force cannot pass through a conductor, but electric line of force can pass through an insulator. This is all about related with this module. In another module, I will come again. Dear students, the content used in video is comprised of NCERT reference books and different sites of Google. Sanjay Sharma, HOD Physics, Rishikul Vidyapeeth, Sonipat.